Hi everyone, Ms. Stillman here. This is the homework 5 key. When we take a look at number 1, you're going to see that there are two chords that intersect. I'm just going to block off the work for a moment. I'm also underlining key numbers and finding a B, labeling the diagram with these numbers. And because we don't know EB, that's the piece of the chord, we put an X there. Even though I want to find AB at the end, we first do the piece. These are lengths of segments. We multiply them. I made a note that we're going to find the whole chord later. Multiply them, divide by 16, and you get 15.75. Then you take the pieces of 16 and that 15.75, and you add them up and get 31.75. On the next question, it's very similar. These are chords that intersect, so you're doing multiplication. The only difference is this time the chords are intersecting. One chord is a diameter, the other chord is intersecting it. So those lines are going to be parallel to each other, perpendicular to each other, and when they form right angles, then the chord is cut exactly in half. Look at how the diagram is labeled X and X. So now we multiply. X times X equals 4 times 25, get X squared equals 100, but you need to square root of X is 10. Now I've labeled the diagram with 10 for both X's because they want us to find AB. So now I have that reference on my picture to add 10 plus 10 is 20. Number 3, in the diagram below, OR is a radius and RS is a tangent. If TS is 10 and OR equals 6, what is the length of tangent RS nearest 100th? Notice I've stressed that OR is a radius because when I went to label it, I realized OR being a radius will help me on OT. Now I need OT because TS was told to me to be 10. And that's not the length of the entire side of the triangle there. OS, 10 is only part of it. So I need the OT being 6, TS being 10. The entire side is 16. Now it's also important to remember that when a radius meets a tangent, you get a right angle where it meets the circle, right there at R. That means across from R is OS, which is the hypotenuse. Look at my note. I made these notes to myself to make sure I have the proper vocabulary and proper ingredients to plug into the formula. Well, now I realize the formula is Pythagorean theorem. The hypotenuse is the 16. It's the longest side. 6 squared plus x squared is 16 squared. Take a look at the math there and look at how we square root 220 and we're asked to round to nearest 100th. The 8 is the 10th place. 3 is the 100th place. So that 3 either stays the same or rounds up. Next to it is a 2. Oh yeah, it stays the same. So it's 0.83 in the answer. Okay, second page also has a chord question. And in this diagram, we didn't have any labels, so we had to use the words of the question. So to start off with, let's read it. In the diagram below, chords DF and EG intersect at H. EH is 2. Okay, take 2. HG is 10. Put the 10. And DH exceeds HF by 1. Find the measure of DF, and the diagram is not drawn to scale. Okay, when there's a comparison, there are variables involved. Think back to algebra. Exceed means bigger or add. So that original side, HF, is going to be exceeded by 1. So HF is the comparison. HF is the regular X. And DH is the bigger one. DH exceeds HF, so DH has to be bigger. So DH gets the X plus 1. Now that we have the numbers written on the chords and the pieces of chords specifically, we will then set up the question. The equation will be multiplying them. X times X plus 1, 2 times 10. Notice we have to distribute the X to X, and X times 1, you get X squared plus X is 20. The way we solve that is getting all the numbers on the left side. You want to get equal to 0. By moving the 20, by subtracting it to the other side, you get equal 0 on the right side. You have a trinomial. We need to factor the trinomial. You would start by putting parentheses and putting the x's, because we know x times x is x squared, but then you have to figure out what numbers multiply to negative 20. So think 1 times 20, 2 times 10, 4 times 5. And I would need one number to have a negative. So right now I started with -1, -2, -4. I would want to see which of those adds to +1. So let's look back. We multiply to negative 20, add to +1. Making 5 and 4 go to become 1 would be perfect. -4 plus 5 will work. If I did -5 plus 4, I would get a -1. We don't want that. We want +1. put in the -4, put in the +5. Each of those gets equal to 0. Look how x is equal to 4 and x is equal to -5. Now, just like a previous unit, we remembered to write that it does not equal the negative number because you can't have a negative length. In a geometry question, you cannot have a negative length. So that 4 is the answer. And then you also need to plug back into this segment, DH. That's 4 plus 1, which is 5. Now we want the final answer to be all of DF, D all the way to F. That's 5 and 4 together, which is 9. The next question is with secants and tangents. Mr. Krieger and I are going over this formula that tangent squared equals whole times outside. We like to write the formula down first and then plug the numbers in. The tangent is the side that only has one number on it, and it touches the circle one time. That's x squared right there. And it's whole 27 times the outside segment of 15. Take a look at the math. 4 or 5 you get when you multiply the two numbers. And we want simplest radical form. So you test out other perfect squares, but the largest perfect square and the best perfect square is 81. 4 or 5 divided by 81 is 5, so 81 times 5. And then the square root of 81 is 9, so AD equals 9 square root 5. On the last page, instead of having a tangent, we have two secants, so we just continue doing whole times outside equals whole times outside. Now you're going to notice I really emphasize the brackets because you're going to notice sometimes you don't have the whole and you need to put pieces together to get the whole. So MN is 8, NP is 10. Look at the two pieces. I need the whole. Add them together, get 18. On the other side, SP is the 16, and we don't know RP. RP is located in the perfect location to find. It's the outside segment, so we put an X there. The outside segment, or even the whole, is much easier to find directly. The inside would require an extra step. Okay, so now we take the whole 18 times the outside of 10, the whole 16 times the outside of X, and you get 11.25. On number 7, this is the example where the tangents that touch outside a circle are equal in length. We started off with 124, but both tangents here are 24. AB was a whole 74, so 79. It gave us the entire side of the triangle with 24 and this unknown tangent together totaling 79. So remember, we can do subtraction for that. Take the total of 79, subtract away the 24 that we know, and then this tangent is 55, which means the bottom side here, EFFB, is also 55. And then DC was 28, so the other tangent touching C is 28. Well, now we just add up the segments, and you get 214. The last question, you have a chord and there's a distance from the center to the chord that meets at a right angle, and then the radius is what you're looking for. Notice that there were no radii drawn in on your paper initially, but hopefully you knew to connect O to B. You could have done O to A. As long as you have one radius and you have a right angle, it's in angle OMB. And you have a right triangle. You really recognize that. This question is the type of question where you see, oh yeah, draw the radius, I have a right triangle, I need to do Pythagorean theorem. So we had 4 and 11. We didn't have 11 at first, we had 22. 22 is the entire length of AB, but when the distance here comes across and hits the chord, it splits it in half. So you have 11 and 11 on AM and MB. So 4 and 11 are on one right triangle. Plug them in. 16 plus 121 you get after you square each number. It's equal to x squared. 137 equals x squared. Square root both sides and you get 11.7046 ... Now nearest 10th, take a look at the 10th place, the 7. Next to it is the 0, so you leave it as 11.7.